everyone, welcome back to Dragonfly Engineering. This is the third episode in the basic mold making series, which hopefully this episode we're going to finish the mold up so we can load it onto the molding machine. So stay tuned and see how we finish up this mold. Oh, and if you haven't seen basic mold making 1 or 2, which are the 2 previous episodes in this little mini series, then I recommend checking that out so you can see how we got to where we are now. All right, thanks. Oh yeah, and this week's added content at the end of the show, I'm thinking I'm going to show a luge track that my friends and I went on last summer in Switzerland, in Lauterbrunnen area, or is it Grindelwald? All right, so at the end of the last episode, we were grinding these ejector pins to height. You can see how they go through the hole here. And I was showing you how to measure the remaining amount of material to grind off the pin such that the top of the pin is flush to the mold surface using calipers like this. I was under the weather at the time and I really don't know what I was thinking, but this is a way you can measure the height. I think I got 16 thousandths, but it's not a very good way because you can get angular error called sine error, so you get a different measurement this way versus that way. But the whole time I had a surface plate right behind me, which does much more accurate height measurements. All right, so on the surface plate here, we've got, so this is a granite surface plate with a flatness of probably 2 microns over a 2 by 3 foot surface area. And usually most mold making or most shops do need a flat granite surface for doing measurements. The other key thing that's needed for a granite is you can see I marked the granite with the aluminum there when I moved the mold. But you need this a depth gauge. This depth gauge I bought at a moving auction recently, and it's a Mitutoyo, and it measures with this dial and this counter here, height up to I think 16 inches. And then typically you have another dial indicator, a depth gauge on the boom. So to measure the height difference of the ejector pin to the mold surface, what we're going to do is come down with the hand knob here and touch off on we can touch off on the mold surface first. And it doesn't really matter how deep you go, you just want to make sure that you're engaged in the mold surface so the needle starts moving. And then you can move actually let me see if you can zoom in on, let me zoom in on this some more. So one of the tricks is you spin the bezel on your depth gauge until your needle hits 0 here. And then after we've set our reference height, which is the bottom of the mold, then we can lift up the needle or the plunger on the depth gauge here and then move the mold over to where the ejector pin is and then get a difference. So if we look at that dimension, it looks like it is 18.5 thousandths. We're using the hand calipers with an uncontrolled orientation. I got like 16 thousandths. So this is telling me I need to take 18.5 thousandths off, and we can double check this by you can pull the plunger up and say 18.5 thousandths. And then we can lift up again and then move back to the mold surface and make sure that the needle goes back to 0, which it does. So this is telling me that I need to grind 18.5 thousandths off the top of this ejector pin such that the ejector pin is flush with the mold cavity surface. And then I'll repeat the same measurement technique on the other ejector pin as well. All right, so we're going to use the same fixture setup that we modified in the last episode, the little EDM pocket at the bottom so that the ejector base would fit into this fixture. So let's stick that guy in there. Actually, I'll raise up the stone. This is a Grizzly Industries surface grinder. Which so far works great. The only complaint I had was the tool to dress the stone was basically worthless. So if you buy one of these, you need to buy a diamond tipped stone dresser. And what this does is you put this guy on the magnet and you bring the stone down and you grind off a fresh surface on the bottom of your stone. the stone dresser that came with the Grizzly Industry grinder basically just rubbed on the stone and made it worse instead of better. It created like a worn rub, a shiny spot on the stone, which burns your steel whenever you're grinding it. So yeah, throw away the one the dressing stone that came with the grinder and buy one from an actual tool and supply company that's got diamond on it, and you'll have much better results. Well, I got that on there now, so, but I've already dressed this stone, so we'll go ahead and set the height. Some of this I did in the last episode, so this is a little bit of a rehash, but I did want to point out how to correctly enter the grinder, how to bring your work into the stone. So then the stone rotates this direction, so it wants to shoot your part out that way. So what you don't want to do is come in to the stone when you're setting the height from this direction, because if your height is wrong, the stone will grab your part and basically jam down on it and either shoot the part out at like Mach 3 or explode your stone, both of which are bad. So when you're setting up your grinding operation, you want to come in from the up rotation side. So the worst that'll happen is basically your part will just lean out a little bit if you got your heights all wrong. You also want to come in from the edge so that you don't engage the entire surface if you did something wrong in your setup. So these are all just safety things that you should do, and always keep this cover on. And of course safety glasses as well. So with my part out of the stone, I'll turn it on, and basically you just want to go back and forth and reach across the frame, and I'm slowly bringing the stone down and just sensing to see where we're at. Now I am going back and forth now because I know that the stone's not hitting, and it'll just start grazing the surface just like that, and you can kind of hear it. And now I'm going to advance the part across the stone to ensure that I've got good coverage and there's not like an angle in the surface that's going to gouge down into the steel. So once you know that you've established a nice safe flat on your part, I'll record the height here, and we need to take 18. I probably just took about half a thousandths off, so to be safe we'll just take 18 thousandths off the height of this thing. So I'll go ahead and do that now, and probably come down at thousandths at a time. So we're at 26 thousandths, so I just went to 27, and we'll go back and forth. There's a whole lot of back and forth with this. So this is another thousandths. And we'll just do this until we're down to the final height that we want. All right, so I ground both ejector pins to the height that we prescribed, and now we can measure and check here. So I've already brought the indicator down and set the bezel to 0. We're sitting on the base of the mold. So now I'll lift up, you don't really want to slide these indicators around. Lift this guy and then drop it down. And it looks like we're about half a thousandths high, which I guess adds up because I said 18.5 thousandths, but on the grinder I thought I took a half thousandths off when I was finding the height of the existing pin, but maybe I didn't. So we're about half a thousandths high, but I'm not going to worry about that because this is just a test coupon to test the shrink of the plastic in these 1-inch squares that we're going to mold. So this isn't actually for a product or anything. The next step is going to be grinding the bearings for the ejector plate, which are also called return pins, and we need to grind those pins to be flat against this surface because the return pin's function is to guide the ejector plate, which moves these ejector pins up and down, but it also forces the ejector plate to return to its home position if for some reason the ejector plate is forward when the molding machine closes. The pin that would be in this hole will push down the ejector plate, or the molding machine will sense that something's not right and then stop. So it's kind of a safety feature that these pins that we're going to stick in these guide holes are also flush to the surface of the mold. So we'll do that next. All right, so here's a blank 3/8 inch ejector pin. This is the guide pin and the return pin that I just mentioned. So we'll kind of follow the same process. I'll kind of stick it onto the stand-in plate for the ejector plate, and then we'll just mark roughly where to cut with the die grinder on the pin here, making sure there's excess because die grinding isn't that accurate. So this is just a 1/16 cutoff wheel and an angle grinder here. All right, using the Home Depot grinder here, we'll just grind a general flat onto this guy. This is mostly just to get us close for the surface grinder so I don't catch the stone. Can't really hold it against the bottom plate because of this step here, so I'm kind of levitating it. Always be careful with that too. All right, so I ground the return pin here. You can see how the surface as well. And so now what we need to do is fit test this, and I actually already tested this, and the pin fits into this linear sleeve bearing just fine. And it also fits into the reamed hole in the mold, but it doesn't fit through both of them. This is because there's a slight misalignment probably between this bearing and the reamed hole, and since everything is under 1/1000ths for clearance, there's just the tolerance stack doesn't allow this pin to go through. So what I'm going to do, not on the surface plate, is to run this 376/1000ths reamer through, probably run the shaft through the reamed hole and through the bearing so I don't dig up the bearing, and open this hole up a little bit and see what we can do. So I'll move over to the bench. Let's go ahead and ream out this hole. I'm looking just to try to avoid hitting the bearing. Yeah, I did it. Yeah, these bearings have like a Teflon lining in there, so we don't want to damage that Teflon lining. All right, so there we got nice, clear, smooth action with the other pins here. This side still needs some work. Still not quite right. All right, I'm gonna mess with this off camera, try to avoid profanity, and get back to you. Okay, so I got this guy reamed out using the 376/1000ths. There's just probably a little bit of a step, like a 1/2 to 1/4 thousandths mismatch between this plain bearing, which is basically just aluminum oxide on the inside, and the aluminum hole in the mold itself. So now you can see it runs nice and smooth. I don't really feel much of a wobble. And that really helps in just the longevity. The tighter but free moving these bearings are, the better the ejector plate will behave. So we got our return pins and our 2 ejector pins. So the next step is to actually fabricate the ejector plate, which ties these pins together. So we're going to use this chunk of stock, which I use to measure and grind the heights. And all of these pins will be referenced by this plate. So the first preview of the ejector plate action is going to be me lifting this plate up, and you can see how all the pins and the return pins eject the part out. And then push, when the mold closes, the A side of the mold pushes these pins down, which pushes the plate down. So that's it. So let's start making our ejector plate stack, which is essentially just a clamp, 2 plates that clamp these pins down. So let's do that next. All right, I'm back here on the CAD system here, or the CAM system, to show how we're going to program and cut out the key features of the ejector plate system. So you can see here this highlighted square here is going to be manually machined square plate of aluminum from the piece that we've been using. And then over here is going to be screw holes that are going to be drilled and tapped, as well as pilot holes for machining and drilling the ejector pin holes. So these outer rows of holes are going to be 832 threaded holes that essentially screw the two plates together that are pinching the ejector pins. This is the tapping operation with an 832 screw. And then this operation here is going to be machining pockets that house the feet of these ejector pins. So I'm basically machining the top and bottom plate of the ejector system using a single cam program. I'm going to use features of various features at different times. And of course, Sierra is knocking the camera tripod as we speak. Sorry about that. Yeah, so we're going to be, I'm going to cut out the stock next and square it, and then we'll load it into the Haas TM1 mill and then run these operations, both pocketing and drilling and tapping. So let's head over to the stockpile. No more camera banging? You're down? You understand, Sierra? No, good? Okay, thanks. Okay, so this is the plate that we use to set the grinder height. So this will be the bottom of the ejector plate system. And then this piece of aluminum stock, it looks like it's just big enough. So I'm gonna mark with a marker. I used to have a little plastic circle in here, which is covers the gap for when you change the blade, but that long went away, so I put a piece of sheet metal on the table and just sawed a cut up to the spot where I'm working. So yeah, it's pretty straightforward. We'll just cut these out. All right, I'm over here at the Haas TM1 mill. This is the first CNC mill that I got. Had it in my garage at the house for the longest time. Yeah, so we're gonna load these two plates that I just sawed out with the, I guess the mill edge, which is kind of a clean edge. We can put that down into the vise. These ejector plates are not at all critical, so I'm not even worrying about parallels. We're just going to use the bottom surface of the vise itself, or this reference surface. So let's load this guy on here. And then I'm going to basically manually square these blocks up to match the profile of the ejector plate that we were looking at on the computer. So this machine has a tool changer as well. There's 10 tools and a carousel on this side. And you use G-code over here on the controller, which you probably can't see in frame. But I'm going to give it a command M6T7, which is tool number 7, and which is a 1/2 inch end mill. Okay, so go to MDI page and then cycle start, and the machine will change tool to tool 7, which was a 3/16 ball end mill. And I can pull that out and stick it over here, and then we can load the 1/2 inch into tool 7. I usually put 1/2 inch tools in tool 7. I think it's what I set up the first time I ever programmed a multi-tool CNC, so I kind of just stick with that format. So I'll double check the vise, and then we can square up our stock here. I just basically jogging with this hand wheel, using the CNC like it's a manual mill. I got a 2000 RPM. I've already warmed up the spindle. It is a good idea to warm up your spindle if you're going to go to high RPM, just so you're not thermally shocking and jamming up bearings inside of your spindle. Same goes for when you stop using a spindle at high RPM. You want to do a spindle cool down, so you let it spin at 1000 RPM for 10 minutes or so. But we're going to basically just take off the bulk and just clean these plates up. This is mostly just for cosmetic reasons and for finding the center of the part. The design as in the CAD system or CAM system is the plates are 70 millimeters wide. So I'm going to just measure the height here, and I'm at 71.23 right now. I'm not even going to clean up the mill side of the aluminum, but we'll just drop down from the origin I just set. What did I say? 1.22 millimeters. Actually, we'll see how good or bad this wound up being. So we're at 70.07, so we're about 2.5 thousandths over. But you know, as you can, oh, and here we're at 69.95, or no, 69.97. So it's not perfect, and basically it was driven by the roughness of this bottom edge here. But you know, who cares? Double check that your mill's tight so you don't shoot apart. And we'll just skim cut this so that we have a reference corner and a decent looking edge. So that looks, yeah, that's good enough. All right, so here's the corner clamp. Basically, it's pretty simple. It's spring loaded, and you clamp it onto the back jaw of your vise with just a hex key, like so. Then we can bring the stock up to that corner, and then we can lock down the vise. So when we machine the next part, which has the same kind of reference corner, we don't have to reset up and find the corner again. We can just stick the new piece right there where the old piece is. So now what we need to do is edge find this corner and this corner, since our 0 is there. All right, so here's the wobbler. Let me bring it in so you can see here. You can zoom in on it. Yeah, and this end flops back and forth as the part is spinning and tells you that you're on the edge of your machine part. So let me go ahead and load that guy in here. I like to do 1200 RPM, so 1200 and then clockwise on the lathe, or on the mill controller. And then I'll manually bring this guy down again. Let me get the coolant out of there. Let me zoom in so you can see a little better what I'm doing. Okay, and then by looking at the edge finder, we can slowly move in on the wobbling part of this tool until you see it kind of get concentric with the shaft, and then it kind of knocks out to the left or right. And as soon as it kicks out with a little step in the shaft, that's telling you that it's on the edge of the aluminum workpiece. So I'm just gently coming in, slower and slower, and then we will see it kick out any minute now. There it goes. I like to do it a couple of times. You know, I'm moving half a thousandths at a time here, or 10 microns. Okay, so that's the spot. So now we'll pull out and then do an offset. I'll say that is offset measured, and then I will jog over 2.5 millimeters, or 2.54 millimeters, which is 0.1 inches, which is half the diameter of that guy again, and then do an offset X, and then part 0 set again. And that told me that, okay, that's 0. So now if I go to the controller and I tell it to move to X0, Y0, and cycle start, it will move to the corner of this stock, and that is our location for the program. All right, so I've moved the tool from in the carousel to tool number 4, which is typically what I use for a drill bit. So this is a drill for tapping an 832 hole in aluminum. And this chuck is just kind of like a Jacob's chuck. You just hand tighten it. So now I'm going to go and set the tool height of this drill to the top of this stock. So this first piece is going to be the base, which is the piece that we're using to define the grind height of the ejector pins. So I'm going to set this tool offset or tell it to measure this tool offset. And then the next tool is going to be a tap, which is going to be tool number 5. So I'll say next tool, and it should go ahead and do a tool change to tool number 5. And I think there's an 832 tap in here because I always put taps in tool number 5 ever since day one when the first program I ever wrote on this thing. I think that's 832, but I should double check just to make sure because I hate to bust a tap off in this thing. So I'll be right back. Drills and taps, you know, the tool height isn't critical, but you can't crash it in there, of course. So tool offset. And then we're also going to drill and tap for a half 13 hole in the middle, and that hole is what the molding machine engages, or a half 13 rod screws into the back of the ejector plate to advance the ejector plate forward and back. So we have a 1/2 inch 13 in the tool carousel at tool number 6 location. This guy right here. So let's go ahead and set the height of tool number 6. M6T6. Cycle start. And tell it tool 6, tool measure. Let's see, so there's a big chuck in position number 9, so we'll do the pilot hole and drill chuck number 9 for that one.
Let's see, we're zoomed out, so I'll double check I set the tool and then go to MBI M6T9. And this guy needs a drill chuck.
Okay, so I selected the portions of the cam program to machine the base side of the ejector plate. So it's loaded up, and let's go ahead and hit go. Okay, so now I loaded the next portion of the program and the cam system that will cut the top of the ejector plate, which has little pockets and threaded holes to clamp down all the ejector pins. So let's go ahead and let her rip. So, I cleaned up our ejector plate system a little bit, and you can see how it's assembled here. I usually just use a rotary palm sander for woodworking to get a real quick and dirty finish on aluminum parts. So here is our ejector pins and return pins through the holes we drilled. I think you can see that. I drilled these holes a little oversized so that we don't over constrain the travel of the pins. You basically let the pins find their happy location, and then you clamp it all down with the back plate, like so. The center ejector or sprue ejector pin here doesn't have a countersink because there's a overlapping half 13 bolt hole here, which when we load this mold into the molding machine, there's going to be long threaded rod that goes in here, and it clamps the ejector pin in place and is the rod that actuates the whole ejector plate back and forth. So let's go ahead and assemble our ejector pins onto our mold back here, and hopefully I didn't forget anything. So we can set this guy up like so. Usually you got to string these pins in one at a time because, or you got to countersink all these holes to guide the pins in, because getting a whole bunch of ejector pins to line up simultaneously is basically impossible. So another technique is to just put the plate up against the back of your mold and string one pin in at a time, as you can see I'm doing here. So this is a return pin, and oh, here's the ejector pin that we want. We'll string that guy through. This is our gate or our sprue ejector pin. That one felt a little tight. And then the other return pin at the bottom. Make sure you can see all this. Okay, and then there's our pins, and then we stick our clamping plate on the back. You probably saw that I countersunk these holes for a screw head because we designed these pins, the length of these pins, to sit on this plate without a screw head protruding. So yeah, the next step, I think I got the screws here in my pocket, is we screw our plate on. Okay, now this should slide real smooth, and you can see how we are ejecting the part. Something felt tight there. So yeah, that works pretty good. So that is the ejector system. Okay, so the next step is we will mount the back of our mold, the riser blocks and the back plate on, making sure this is clean, and these are clean, like so, and like that. Then I'll have to get some 3/8 bolts here, so let me sign off for a second. Okay, I'm back with some 3/8 bolts. Nothing special about them. Okay, so that is the bottom half of our mold. You can see how well the ejector pin wants to travel. Oh, I flipped these. These two pins are flipped, so I have to fix that. I'll be right back. So the final step that we need to do for this mold is to press in the alignment pins that align the A side of the mold to the B side of the mold, and we're going to do that with these 1/2" dowel pins that you can see right here. So let me go ahead and get those started. Usually I hammer them in with a square, and then I use the mill vise to press them in. So let's go ahead and do that. So I did test these press fit holes on the mill, so let's see how well they stick. That seems like a good start. Let me grab a 1, 2, 3 block. And for those that don't know, a 1, 2, 3 block is 1 inch by 2 inches by 3 inches, and they're used for measurement. And anyway, they're good for making sure your pin is square. So I can whack on this pin, and it's not a good idea to use your measurement tool as a hammer, but you know, these are pretty cheap. Let me get this guy started, and we'll check both axes. Pins can be driven into pre-machined holes crookedly. They just wind up taking the direction that they're started at, and they'll just gouge out the inside of your hole. So if you have got a perfectly machined hole, it doesn't necessarily mean your pin is going to go in there square. So what I'm doing is I'm pre-aligning this pin into my hole to make sure that when I press it with the vise, it will continue on the correct track, if you will. Let's hammer this guy in next. Okay, so that's square. So now we'll go over to the mill vise and press these pins into place. All right, I'm over here on the manual mill, and which one day will get its CNC retrofit, but for now it's a manual mill. And I'm just using the Kurt vise here to press these pins in. Sometimes you can lubricate the pins, sometimes you can heat up the aluminum block, but in this case I think it's just going to go in pretty well. You get about a ton of force with a Kurt vise. You don't want to overdo it because you can bend your handle or damage your vise. But it looks like this is going in pretty good. And I only really, oh, and I never leveled this mill, so you can see how it's moving around from when I moved in. But we only really need to go as deep as the bearing hole is in the mold, and that's it. So let's see how far we can go. Sometimes it's a good idea to double check your alignment before you go too deep, but I think we're good here.
All right, so that was the first one. Flip over to the second guide pin. And we'll press this guy in.
Okay, well, I think we're just about at a wrap here for this mold and this series of basic mold making. I want to remind everyone that this is a very basic mold, so alignment pins are not here, or there's not even a mold cavity on the A side. The purpose of this mold is to mold a test coupon that's 1 inch by 2 inches exactly, with various plastics, and then measure what the mold shrink is for the part that comes out of the mold. But to recap the operation, the A side has basically a flat with alignment pins that line up with these bearing holes, which are linear plane bearings. So this guy aligns like that. It's a pretty tight fit because it's a basically zero tolerance fit. So I'm not going to go through the fuss of pushing it in, but yeah, that guy aligns to this side. One thing that I will have to do is use this tapered drill to put a taper in the sprue here, because the plastic enters through this nozzle and then passes through the thickness of the mold. And right now there's a straight 1/8 inch hole, so the plastic sprue would tend to get stuck in this mold a lot. So we're gonna drill in a taper, which takes a little bit of time. You just got to be real slow because you wind up using the entire face of the drill bit to remove material. Then the B side has our ejector plate in it, which moves forward, and then you can see how the ejector pins push the part out of the mold cavity and then return. And then the molding machine grabs onto this threaded rod at the back, which actuates the ejector plate back and forth like that. A couple other things I'm going to add is, which typically you add, this is a cartridge heater, which is essentially just an electric resistor that's in a steel jacket. I'm going to drill some holes and then insert these cartridge heaters into the mold, because typically, depending on what plastic you want to heat up the mold to properly receive the molten plastic coming into the mold cavity. And also a temperature sensor so this is an M6 threaded temperature sensor, and so I'm going to drop a M6 threaded hole into this mold as well, probably both sides of the mold, A and B. So with that, I'd say this is a wrap for the mold making, the basic mold making series. I would like to also wish everyone a happy holidays, and stay tuned for the next show where we're going to load this mold into the molding machine, and we're going to go through the operation of loading a mold and running a molding machine to mold parts out of this particular mold right here. Yeah, so again, happy holidays, and don't forget to stay tuned for the added content, which is riding a stainless steel luge in Grindelwald, Switzerland. All right, I'll talk to you guys in about a week. Bye.